Hey everyone, and welcome. Today, we're diving into a really cool concept in mensuration. What actually happens when you take a solid object, melt it down, and reshape it into something completely new? You know, like turning a big block of wax into a candle, or a lump of clay into a sphere. Let's jump right in. So, let's kick things off with a big question. If you take a solid, melt it, and then pour it into a new shape, does its volume, the amount of stuff it's made of, actually change? Just think about that for a moment. This is the central puzzle we're going to solve, and the answer is the key to everything in this topic. So, what is this conversion of solids anyway? I know, it might sound like some complicated math term, but the truth is, the idea behind it is something you see all the time, everywhere from your kitchen to a factory floor. Seriously, this idea is incredibly practical. When a candle maker melts a big old chunk of wax to pour into molds, that's conversion. When an artist takes a lump of clay and shapes it into a pot, that's conversion too. Same thing goes from melting down metal to make jewelry or wires. In every single one of these cases, the shape totally changes, but the amount of material you started with, that stays exactly the same. And check this out. This picture illustrates the point perfectly. Here you've got a group making candles. They start with a big rectangular block of wax, that's a cuboid, and they melt it all down to create these nice cylindrical candles. The shape is completely different, right? But the amount of wax they began with is the exact same amount of wax that ends up in all those finished candles. This brings us to the single most important rule in this entire chapter. Honestly, if you remember this one thing, this one golden rule, it will unlock every single problem you face. And here it is, the principle of conservation of volume. It sounds a little fancy, but all it means is this. No matter how you melt it, bend it, or reshape a solid object, its volume, the actual space it takes up, does not change. The surface area might change, the dimensions will definitely change, but the volume, it's constant. So what this all boiled down to is this one simple, powerful equation. The volume of the shape you start with is always equal to the volume of the shape you end with. This is the only formula you really need to memorize for this concept. Everything else is just about using the right volume formulas for the shapes you're given. All right, that's enough theory, right? Let's see how this golden rule actually works when the rubber hits the road. We're going to walk through a couple of classic examples, the kind you're almost guaranteed to see on your exams. Okay, problem number 1. Imagine we have a cone made of modeling clay. We know its height is 24 centimeters, and its base radius is 6. Then a child comes along, squishes it all up, and rolls it into a perfect sphere. Our job is to figure out the radius of this new sphere. So how do we solve this? Well, we just need the volume formulas for our two shapes, the cone we started with and the sphere we ended with. On the left, you've got the volume of a cone, and on the right, the volume of a sphere. And according to our golden rule, we know these two have to be equal. So we just set the formulas equal to each other. The volume of the sphere equals the volume of the cone. Now, before you start plugging in numbers, here's a pro tip. Simplify first. Notice that pi is on both sides? We can cancel that out. The 3 in the denominator is on both sides too, so we can cancel that as well. See? The calculation just got way simpler. And after you solve for r, what do you find? The radius of the new sphere is 6 centimeters. It's really that straightforward. The amount of clay didn't change, so we could use its volume to find the missing dimension of the new shape. Let's tackle another one. Now, this is a really common type of exam question. You take a metal sphere, you melt it down, and you pull it into a long, thin wire. Now, don't let the word wire confuse you. A wire is just a very, very long and skinny cylinder. Our goal is to find its length. So, what's our first move? You guessed it, we apply the rule. The volume of the original sphere has to be equal to the volume of the new cylinder, which is our wire. We just need to line up the formulas. Now, we plug in the values we know, but be careful here. The question gives us diameters, but the formulas use radius, so you have to remember to divide by 2 first. Once you substitute the correct values and solve for h, which represents the length of our wire, you get 3,600 centimeters. But hold on, we're not quite done, and this is a classic exam trap, so pay attention. The answer is in centimeters, but often the question will ask for it in meters. 3,600 centimeters is equal to 36 meters. Wow, think about that. You get a 36-meter-long wire from a pretty small sphere. So now that you've seen this in action a couple of times, let's break it down into a simple, repeatable strategy, a 4-step plan you can use to solve any conversion problem they throw at you. Here it is, your 4-step plan for success. First, identify your starting shape and write down what you know about it. Second, do the same for your final shape. Third, this is the magic step, set their volume formulas equal to each other. And finally, step 4, just plug in all your numbers and solve for the one you don't know. Follow these steps, and you'll be golden. Okay, let's talk about exams for a minute. To get those top marks, it's not just about knowing the method, it's also about knowing how to avoid the common traps that a lot of students fall into. Here are the top 3 mistakes you need to watch out for. First, and this is the biggest one, never use surface area. The surface area almost always changes when you reshape something. It is always about volume. Second, you have got to know your volume formulas by heart. Make flashcards, quiz yourself, whatever it takes. And third, always double-check your units. A simple mistake converting from centimeters to meters can cost you easy marks. So, if you're practicing for your exams, where should you focus your energy? While certain types of questions on this topic come up again and again, let's make sure you're ready for them. Think of this as your study checklist. You absolutely want to be comfortable solving each of these scenarios. Melting a sphere into a wire. We just did that one. Converting a big block into lots of smaller items, like making many small bullets from a large piece of lead, or a block of wax into several candles, and of course, reshaping clay. If you can master these, you are going to be in fantastic shape for your exam. So let's end right where we started, with the one single idea you must never ever forget. When the shape of a solid changes, its volume does not. This is the most important principle of this entire chapter. If you remember nothing else, remember that. It's the key that unlocks every single one of these problems. Thanks so much for joining me.